Hey scholars, welcome to chapter 15. This week we're looking at non-renewable also versus renewable energy resources. We're going to start with the non-renewables since we're most familiar with those since we use them all the time. So we're going to start today with our case study that actually directly talks about one that we use all the time, and that's oil. And our case study is looking at how long will the supplies of conventional oil last. So obviously since you were born, I was born, our parents were born, we've used oil for a lot and as our main fuel source. The problem with it is like it's hard to speculate how much is left. We know there's not a lot left as far as resources go, or the prices wouldn't continue to rise. So when will we run out? Again, there's no specific time frame. People don't know exactly when it's going to run out, but they have some predictions on when they might run out. There's a website that I'm going to link below this video today that shows you maybe exactly when that oil might run out, but again, it's not an exact figure. It's just based off of what OPEC has showed us as far as the numbers of barrels of oil are left. So I'll post that for you. Take a look at it. There's also a bunch of other cool stats too. It's by worldometer.info, and I'll show you that a little bit later. There are three options though with oil. You either can look for more and try to make more of the, or not make more, but find more of that resource and then use it. You can reduce oil use overall and waste less of it. That might keep your now current supplies intact for at least a longer period of time, or use other energy sources. And that's kind of where we're at as far as society goes right now, is what else can we use besides oil, or at least to limit our oil usage overall. There really is no easy solution, especially as a society when you get hooked on one specific type of energy resource that we used over, I don't know, hundreds of years. So this is just looking at a Thunder Horse offshore floating oil production platform in the Gulf of Mexico, one of those offshore drillings of oil that we've been using for, like I said, a long time. What major source of energy do we use? So we're going to take a look at that. That's what are our major sources that we use. What could we use in the future? That's what we're going to explore in this chapter. But what have we used so far? And again, most of those are non-renewable. That's what we're talking about with this chapter. So fossil fuels obviously supply most of our commercial energy resources, but one that really provides, again, all of our resources, going back to it, is solar capital and solar energy. Even without the sun, we wouldn't grow plants or grow organisms that eventually die, decompose, then get pressed between layers of soil and rock, and then turn into fossil fuels millions of years later. So even without the sun, we would have no energy whatsoever, because the solar energy technically, in a way indirect form, produce all the fossil fuels that you use today. It also produces some renewable ones indirectly in the form of wind. We know that the uneven heating of the Earth's surface produces wind currents, which we kind of looked at again last chapter. It also provides hydropower, which is the movement of currents and water. So that's another one that can be an indirect form of solar energy, another renewable source. And also biomass, the growth of organisms here on the surface of the planet, and then using whatever energy they have inside of them as a fuel source. That's another example of an indirect form of solar energy. Without the sun, plants don't grow, organisms don't grow, and therefore all life is lost, really. So commercial energy itself, we're looking at this chapter, and there are two types of forms: non-renewable energy resources like fossil fuels, which can include coal, oil, natural gas, oil. All those are types of non-renewable ones. Then we have renewable energy resources such as biomass, hydropower, geothermal, wind, and solar energy. And so that's what we're going to be looking at with this chapter, looking at those two different forms. We're going to save the renewable ones for next chapter. We're going to really focus on those non-renewables this time. So the natural capital itself is an important non-renewable energy resource. It definitely provides all of those non-renewable ones that you saw. There is oil storage, again, oil trapped beneath the Earth's surface, natural gas, and oil are very, very closely linked. We'll look at that a little bit later. Even water heated and brought by dry steam or wet steam, that's geothermal. We have coal that's built up over into rock layers, which shown here as well, underground coal mines. There's also gas wells and oil off the shore as well. So there's many different areas to be tapped into as far as non-renewable resources, and we have tapped into a lot of those so far. This just kind of compares a nice little graph for you, a little pie graph, and really taking a look at parts of a whole, out of all the non-renewable resources, or all the energy resources that we use, the United States versus the world, what are the percentages? So obviously the world uses a little bit less oil than we do. They only use 33%, we're at 39%. We use a little bit more coal than they do, 23% to 22%. Natural gas we use more of, 23% to 21%. they're really on the rise with biomass. 11% to our 3%, hydropower a little bit above us, geothermal a little bit above us, and nuclear we're a little bit more than them. So really on the most part, they are 18% renewable resources, and we're at 7 in the United States. So we're a little bit behind the times and behind the curve as far as jumping on this renewable energy resource bandwagon. So we really need to start looking at ourselves at home here in the United States and how can we get more and almost get up toward these 18%, if not more than that, in the near future. So the case study is just a look at human history and the energy use that we've used in human history. And one of those is muscle power, early humans, the Fred Flintstone era, where they're walking with their feet and moving around. We used ourselves muscle and brawn and strength to provide energy for what we're trying to do. Then we discovered fire, and that was kind of huge. Fire was a big deal, and that really progressed us into using that as a heat source and a cooking source and energy source. We also used agriculture as far as growing crops, using them as an energy resource for ourselves. Use of wind and flowing water, we've done that since the old windmill times of the gold mining days, using windmill to churn water and turn a turbine to produce energy for us. Machines powered by wood and then coal. We went for the wood era, then the coal era. Then we actually went with the internal combustion engine using oil, and then now we've used nuclear energy, and then now we're in an energy crisis because we've kind of focused on, because they were easy to access at the time, all these non-renewable resources instead of really wrapping our brains around these renewable energy resources. Or we just use things like wood, which is a biomass, so unsustainably that we've almost made it a non-renewable resource. So that's kind of where we've been so far and where we're at today. So how should we evaluate energy resources? We got to look at it based on the supplies that we have. What kind of environmental impact does that energy resource have on the environment? And then how much useful energy are we actually getting out of that energy resource? Out of the work we put into it and extracting it, how much are we getting out in the process? So it takes energy to get energy. That's what we're talking about with net energy. You know about the second law of thermodynamics. Not as much energy is passed on as it's transferred or changed. And so the net energy expressed as a net energy ratio. And if you look at conventional oil, the reason why it's been a resource for us is that it does have a high net energy ratio. For the amount of work that we put in to extract it, we actually get a lot of energy out of it. So we're looking at energy put in minus, or energy we're getting minus energy we're putting in is basically our net energy yield. Electricity produced by a nuclear fuel cycle has a very low net energy yield because of the amount of mining that has to go into it to find that ore that is nuclear based or nuclear reactive, and then we have to build the machines to harness it, cool it, all that resource that we put into it. And the end of it, it really has a lower net energy yield than it would if we were using it like a conventional oil system. That's just an example of net energy. We're looking at the highest net energy yield for the least amount of work that we're putting in. That's really what we're looking for. All right, so net energy ratios. This is just for various energy systems. So like space heating your home or heating a space of air or a place. The best one to use is passive solar, which is basically just open up your windows and letting the sun directly come in and heat your home. That's a nice way of doing it. 5.8. As far as, I don't know what those are in. I guess I'll take a look at it for a second here. These are energy ratios. So like a 5.8 to 1 is basically what you're looking at. And natural gas is a little bit under that. Oil is 4.5. Active solar, which is like solar panels in your house, you're getting a lower net energy yield. Using coal, even less. Electric heating and electric really low. So just by plugging those into, and these are if you're plugging an electric heater and you're using the electric company that you're using is a coal-fired plant. This is the electric. If you're plugging into your wall, they use a natural gas-fired plant or a nuclear plant, obviously getting less as we go down. If we're looking at industrial heat, looking at how we're using it in industry, surface mine coal has the highest. Underground mine coal is second. So you get a high yield of coal. Yeah, it's kind of dirty and kind of gross as far as the environment goes. Natural gas, oil, coal gasification, and then direct solar or concentrated solar has the lowest. Transportation. Ethanol from sugarcane residues actually has 8.0. Ethanol from switchgrass is 5.4. Natural gas 4.0, and then gasoline is at 4.1. So we're even today for transportation not using the most energy efficient, I should say, or the highest net energy yield. as far as our energy resource goes. Then coal, oil, shale, and ethanol from corn. Again, because a lot of times the whole, and we'll talk about this later, but ethanol from corn or E85, we used to sell it at the gas pumps. You don't even see it now because we kept trying to use corn as our energy or as our extract or our growth part for ethanol, and that really doesn't work. We'd have to use switchgrass or sugarcane, which are again a big cash crop just like corn is, but we'd have to use those in order to get a higher net energy yield. All right, we'll skip past all those. And that brings us to the end of the first section. We'll see you guys next time when we look at some other specific energy resources.